because I'm going to first start talking about grades. So as I've talked about in the past, actually last night I did completely stay up. So I just, I was just grading all night. It was actually pretty nice to have the time. I don't know what's wrong with me in that I like to post everything all at once, and I'm working on there are some sporadic missing entries for individual students, and then I haven't finished the third lab. So here's what I propose to you guys. I think it's really lame to have the reports graded late. There's a whole background as to why that's happening. I thought a lot about, but there's no reason to really talk about it unless you guys are interested. I apologize. It's really the best I can do. Unfortunately, there's just it's just difficult catching up. When the pandemic hit, it set everything really far behind in research, and so there's just a lot to catch up this semester for that. Anyway, so what I thought I would do is, firstly, I noticed that if there are recurring mistakes, so I have this long document that I have written, and basically I've outlined the points you got for each section of the lab report, and then I've written comments on there that should give you like an overall description of what you've missed. So I'm going to today, I'm going to send each and every one of you individually the list. So starting from the worksheet, the 0 lab to the 4th lab. I guess I can't send you that this afternoon for the 4th lab, but I definitely can for the 3rd lab. I'll send you my individual comments and your scores, your reviewed scores. So it's your homework to look over those. And in particular, if I note that there's a recurring mistake, what I would like you guys to do is you can correct it, and then I'll just give you full points back for that. The way I see it is, if you're making a mistake over and over again, I should have corrected that in the past, and so you shouldn't be taking points off for that. What I also decided to do, because if you guys are going to be flexible, albeit you don't have the choice, I guess, in the matter with me in the grades, I want to be flexible with you for being late. So what I decided to do is for every week that you haven't gotten something, I'm giving you 1 day of flexibility. With the first lab, that was 4 weeks ago, so this is 4 days. The first lab, that was 3 weeks ago. Second, 2 weeks ago. Third was 1 week ago. So it's 4 plus 3 plus 2 plus 1. That's 10 days. So I've actually written this in your lab sheets. Basically, what that means is that it's up to you how to use them, but you have 10 days of flexibility. So if you guys want to submit one report 10 days late, okay, that's all your 10 days. If you want to just submit one report 1 day late, then you have 9 days left. It's going to be more work for me just to make sure that you are using your days and not abusing them, but I want to give you guys some flexibility, since it's not on you that I'm late, it's on me. I haven't thought of anything else at this point. I'd like to do some other kind of revision for reports, but right now the thing that seems most fair to me is just revisions for recurring mistakes. But if I think of something in the future, then I'll let you guys know. Just as okay, and that's about grades. As an overview for today's lecture, I also saw that there's a lot of discussion on Discord yesterday. So what I'll do is, after we go over the pre-lab for this week's stuff, I'm just gonna go over a review of last week, and we'll see if we can sort out your guys' questions. And keep in mind that you have until 5 p.m. today to submit that report. Okay, so with that being said, you guys have any questions, ideally specifically on the homework, but if not, anything else? And if you want to go on, yeah.
Sorry. I had a quick question about resubmitting the older labs. So do you want them just resubmitted in the same like Dropbox with like the name revised as resubmission, or do you want us to email them to you? How do you want that done?
You can just submit it in the Dropbox. That's fine for me. And that's actually a good point. So I should note that you guys can also, if, oh, actually, I don't know how this would work. I was going to say that you could resubmit a report late, like an old report, but that doesn't really make sense. So yeah, so for the revisions, you can submit it whenever, I guess, whenever you have time before the end of the semester. Preferably sooner than later, so that you can fix that mistake so you don't keep making it. But since this is like I don't really feel like there's a time limit for this. Yeah.
Okay, thank you.
So for the revisions, you can submit either just the thing that you've fixed or the entire lab. I don't think it's going to make a big difference because really it's the same amount of work either way. It's just a matter of where you put it. Okay, so we got a request for 6 and 7 on the homework. So do you guys have that? You have your lab manual, does that have it on there? Because the manual I have doesn't actually include this section.
Yeah, so at least in the IDAP, it shows the homework, but it doesn't show the actual lab.
Okay.
But the homework does show up in IDAP.
Okay, so we'll talk about that. We'll go over the pre-lab in a little bit more detail then today. I sent you guys a PDF since you don't have it apparently. I sent you guys so I sent you guys a PDF for for this week's lab about what to do. So understandably, that means you probably want the pre-lab done, which is okay. And what else about that? And there's a video associated with it. This is a little bit of a different lab, but I'm going to go into more detail on that later. First, let's address this homework question. So I just got to pull up the homework.
Hey, Dylan, there
Yeah.
was actually no PDF attached to
Yeah,
that email.
Oh, there wasn't? Oh, shoot.
No.
Okay, let me send it again. Okay. All right.
I also had a question about the new homework that was assigned, because the order was weird to me, because I thought we're doing the redox and activity next, like after that, but it's due after the lab that's supposed to be after that. Like the redox homework is due after the gas one.
Was it gas laws that you guys were given this week? As in, was that the date? Was that the
Oh
one?
no, like it says gas lab redox
Oh, I
is
see.
lab
I see.
6 and
For this week, correct?
also.
That's what you're talking about?
Yeah.
Okay. Yeah, that actually, let me just change that then. That's, did I have the wrong dates on here? Yeah, I'm sorry. That was just me inputting the wrong dates. I'll fix that. Yes, it should definitely be the redox. But let me go over the homework for this week first, and then I'll change I'll update those dates so that you'll have the redox this week. And thanks for catching that. All right, so where's this homework? Six and 7. Okay, so we have, just want to confirm I'm looking at the right one. So we have a question about 6 and 7. Anyone want to talk about those first, or otherwise I'll just jump right into it? like how they went through it? Because I had to take attendance. Okay, so I'll just talk about it. All right, so let's start with 6. So this is a pretty common type of question that basically you'll see throughout chemistry over and over again. So I guess I don't specify what sugar, which maybe could have been more clear, but you could probably just assume it's sucrose. So the first step I would go about this, maybe I could show you guys on like maybe I could show you some work. Whoops. I think maybe I could screen share, but I'll just talk about this over before I do that. So first I would find the molecular weight of sucrose, and then you have grams of sugar. So you have an extrinsic quantity of sugar. You divide it by the intrinsic value of the sucrose, the molar mass. You'll get the moles of sugar or moles of sucrose, and then you divide that by the volume of water, and that will give you the molar concentration. So showing you, this is difficult because I got a lot of stuff pulled up, a lot of tabs and a lot of sheets. So I had to minimize them if I'm going to show you guys everything. Let's see. Okay.
Dylan, I have a question about the lab real quick.
Yeah, which one? The one this week, right?
Yeah.
Or last? Okay.
We don't have an oven.
Okay, so apparently, so there are two answers to this. Firstly, Dr. Fuller has asked if you guys should at least have access to a microwave that you can do the experiment, albeit with some modification. Apparently, I can ask her what she meant by that, because I just saw that as like a basic minimum requirement. However, there's also data that Caleb collects in the video. So even though this is, an experiment you're supposed to do on your own, theoretically, you could just do the same thing that you've done in each experiment so far and just use the pre-collected data. I don't know if Caleb, the video that's in the link, I don't know if he actually gives you the data in the video because she sent us that data as a separate document. So, because he may not focus on that because it's supposed to be a lab that you're doing on your own. Regardless, basically, if it's impossible for you to do it, then I can just send you data.
Okay, thank you.
But otherwise, I'll see how you can do it using a microwave. That seems to be a little bit difficult since we having control over the temperature is a kind of a critical part of the experiment. So I'm not exactly sure the microwave is supposed to work for that, but I will see what she meant, because she was asking for that being a minimum qualification. All right, so 3.4 grams of sucrose. Look up. Yes, whoops. So we want to get the molarity of sucrose in water. So we just take 3.42 grams divided by, whoops. This is a convenient number, as you can see, 342.9. You can see roughly estimate 342.3 grams per mole over, and what we could do here, this actually might make it pretty easy. So we get a nice value here, a factor of, what is this? So 1, 2, and then this is a factor of 3. So that's going to be basically 0.342 grams mole divided by 4.5 liters. It's going to be roughly equal to this. Correct me if I'm wrong, because I'm just doing this in my head right now. I mean, I'm saying it's roughly, it's equivalent to this, not exactly the same thing. And that is, well, let's do this. 0.342 divided by 4. That does not look right.
I think your liters are wrong. It should be 0.045 liters.
So it's supposed to be this. I was trying to see if I could just, so I was going to get it like a fact. This is like roughly a difference of 100, and this is a difference of 1,000. So I was figuring basically if we take this top number, well, I was just trying to do some math in my head that didn't really necessarily work out. So it's fine. We'll just do this the long way. 0.342 divided by 342.3. That looks better. Makes sense?
Dylan, something still looks off.
I got 0.22, not 0.022.
Yeah, I think you shifted one of your decimals. I think you put 0.342 when
Right
it
here.
should have been 3.4.
That right there?
Yeah.
Okay. Or yes.
Well, when you calculated it, you put 3.42 divided by 342. So that's why it was off. Or 0.342. That's what you did. Yeah.
Okay. So, okay. Oops. Yep. That was a problem.
Yeah.
All right, cool. Thank you guys for catching all these problems. Okay. So this is, I'm just gonna get rid of this. All right, so that's roughly 0. Right. Roughly 1/100th of a mole divided by that equals that. Okay, cool. And for number 7, let's see what that asks for. Whoops. This is the only thing I have actually. I don't have the sheet that you guys have. Nice applied question. So first things first, objective 0.25 molar saline solution. We're given 6 molar of sodium chloride and in 4 liters. So let's see the unknowns. We want to, the final volume should be 4 liters. And then we're given this initial thing. So basically we want to find, this is just a dilution. I guess that's what this says. So how is it the simplest way to write this? You could do, what's that formula? M1 V1 equals M2 V2, a very common dilution formula. So the initial molarity, so M1 is equal to 0.25 molar, V1 is equal to unknown, M2 is equal to, I'm sorry, this should be 6.0 molar, M2 is equal to 0.25 molar, and V2 is equal to 4 liters. So there's only one unknown here, and then we can easily solve for this by taking, we can easily solve for V1 by taking M2 V2 divided by M1. So that will give us 6 molar times 4.0 liter divided by, no, sorry, we want, this is our V2 here, I keep missing this, 0.25 molar because it's dilution, 6 molar. These two will cancel each other out. How do I write that with my keyboard? I guess I don't, I can use this thing. I think maybe it's Shift S. So this is equal to roughly 1 liter divided by 6, which is what? I don't know. 1 divided by 6.
It's 0.167.
Yep, thank you. Three sig figs. So this is our volume of liters. They ask you to give you, do they ask for the volume in liters or milliliters? I guess it doesn't really matter. Or for example, if you guys give me something in milliliters, unless it specifically asks, which it doesn't apparently, and it was off, then I would just go back and correct it to make sure that the units, whatever unit you chose, is accepted, because it doesn't specify in this question. Okay. So and yes, I was missing the comments now. So yeah, you guys are both right with the corrections. All right, so that was that. I mean, do you guys have any other questions real quick about the homework for this week? Okay. So this week, so you guys just got the report, the manual basically. So just as an overview, this is the first of 2 experiments that you'll be doing on your own, or at home rather. The second one is a little bit more exciting. So we didn't actually, so this was not formalized really until basically the weekend. So I didn't really have anything myself. Hence why I didn't talk about this last week, because we didn't have anything. But now we do. So fortunately, you guys have something to go over. Basically, if you look at the PDF that I sent you, the objective, I think, kind of interestingly, or maybe I shouldn't say the objective. One of the learning exercises of this lab is understanding how you can how can you measure the amount of a gas as a function of temperature and volume. In other words, we're learning about the ideal gas law, which I don't know if you guys have gone over in lecture, but yeah, but you certainly will pretty soon if you haven't yet. Although I don't know this curriculum, but you will eventually in this in your Gen Chem 1. It's pretty cool. So it's actually a very, I mean, because we do this all the time when we're baking. It's a pretty cool reaction. They show over in the manual too, where sodium bicarbonate, which is baking soda, when exposed to heat, will spontaneously decompose into water and carbon dioxide. And the carbon dioxide is a gas, and as that gas tries to escape, it expands whatever the heck it was kept into. Oh shoot. Sorry. I hope you weren't waiting too long, Benny. I didn't see that you're in the waiting room. Anyway, so the sodium bicarbonate gas is, or I mean, the carbon dioxide has escaped after decomposing from sodium bicarb, and as it does so, it's expanding the binding agent, whatever you're keeping it in. So what's interesting about this is you'll see that when you're baking these things, theoretically, the higher the temperature, the larger the volume of the baked good, of the cookie. Again, it's pretty cool. And then we can actually measure the quantity of carbon dioxide that's produced as a function of the volume. So I think that's pretty neat. And you can also confirm this by analyzing the molecular the molar quantity of sodium bicarbonate to begin with. So I don't know how, if the reaction proceeds all the way, for example, but I would imagine if there's differences in volume, that not every bit of sodium bicarb is going to react depending on the temperature, and so that differential might exist due to some reactions proceeding more than others. With some practical aspect of this, and I guess I can go over let me look at this with you guys. So kind of like we just talked about with M1 V1 equals M2 V2, they are teaching you to the same thing, that the volume and temperature are directly related. Just like concentration and volume are directly related. So okay, so that's kind of the background that you need to know. So the objective is measuring the quantity of carbonate gas through baking these cookies. And we are doing this once again, kind of everything we've been taking measurements this semester have been pretty basic stuff. So a lot of times we're taking masses. In fact, I think basically every lab we've been taking masses. And the first lab we took volume too. So this time we're going back to volume, and then the only thing that we're actually measuring is volume. They give you the formula for the volume of the hemisphere, so you can use that. I would say in terms of practicality, for the procedure for this lab, I don't think you really need to go into in-depth on the actual cookie baking procedure. So in the data sheet, question 1 says for you to write the recipe and the baker who wrote the recipe. I don't think that's just for plagiarism. I think that's so that you don't have to repeat every single aspect of the baking. I would say that like it's fine to just reference that cookie recipe For our sake, for the lab, I would definitely emphasize when you're writing a procedure, the chemistry aspect. So talk about, of course, some basic things that you did to create the cookies, but highlight the actual interesting properties that we're analyzing in terms of the chemistry. So for example, talk about how you measured your sodium bicarbonate, or I mean your baking soda. Talk about how you exactly got the volume, or how you got each of the cookies to be roughly the same mass. So I imagine a lot of people have access to a kitchen scale. I certainly don't. So hopefully you have access to to measuring cups. So for example, you might want to write that in order to get the same volume of each cookie, that you put up to the measuring cup, and then used a knife, which is what Caleb does too in this video, to exactly top it off, and so that roughly everything's the same volume. You can't be perfect about it. There's going to be some variation, but just try to be as analytical as you can. And then indicate especially the temperatures you're using. In your procedure, you don't need to talk about why you're doing it. You just need to mention that you do it, and then talk about how you measured the cookies. Caleb uses, I forgot what's called, but it's like I forgot what they're called, like a caliper. I imagine everyone has access to that, but if you have a ruler, that should be fine.
If we do have some sort of like baking scale or something along those lines, should we use that too?
Yeah, the more accurate you can be, the better.
Okay.
If you can, you should use it, yeah. So I think that's pretty much it for this lab. Do you guys have any questions on that? Okay. So what else can I say? I've been talking this time, so I've only taken a little bit of attendance. So I'm going to take attendance like at the next minute or something. So bear with me. Once I'm finished, you guys can leave. And after that, I'm going to go over a lot more detail on the last week's lab. There were some. The analysis was not as clear, and that's actually just because of the data not being very clear. As in the stuff that we got is what we got, and it should be reflecting something more clearly in like an ideal world, like you saw in the pre-labs, but it didn't, and there's just no way around that. So I think that when you guys are getting confused on the analysis for this lab, that's actually to be expected. That's just the result of poor data, of a poor experiment, basically, on my end. I did what I could, but things don't always work out, unfortunately. Anyway, so we'll talk a little bit about that and just make sure we're all on the right step, but let me take attendance. I should also say that for lab reports in general, you should probably know that the most heavily weighted section is the calculation section. So the objective is worth 5 points and the conclusion is worth 5 points. And the procedure is worth 5 points. The background's worth 10 and the results worth 5, and then the calculations are worth 10. In experiments where you don't have the full lab report, the calculations are worth 20. The results are worth, what is it? I'm just going from memory. It doesn't make sense, actually. I need to go back and look at what I did for lab 2. but just know that this is outlined in the stuff I'll send you later on, so you'll be able to see how much things are worth. But I'm saying this just to keep in mind for the future. It's up to my discretion, I guess, as to where to allow the points. And I personally think that the most important things are the calculations to show that you can do your analysis correctly, and then the background. That's basically how well you understand the theory. I think the objective is also important, so I've given it pretty heavy points for how small it is. The procedure tends to be busy work more than anything else, and it's a lot less useful for this online teaching than it is in real life when you're doing like a lab. For this experiment, for example, the procedure is actually pretty useful because you'll end up using it, and it's something you can go back to. The conclusion is also pretty useful, but I figure just to have the points in a nice, easy distribution, 5 points is what I picked, but I think it's actually weighted higher for the non-full lab reports. Yeah, that's basically it. And then after this pre-lab, which is ending now, anyone who stays over, we'll just talk about the last week's lab. All right, any questions? No, you can't really do any stats here because we don't have any trials. There kind of was, so I saw this in the Discord. Yes, there was only one data collection for part B, and this was actually my fault. I think I talked about it in the video, but that was just a mistake on my part. It shouldn't have mattered anyway, because theoretically they should have been comparable. The second trial should probably been a little bit heavier than the first trial, or actually probably would have been lighter, all things considered, since there would have been sulfur that would have been sublimed off. Regardless, the second trial would have been the more important one anyway, because that's the one with having some rid of extra sulfur. It would have been good quality control just to make sure that the sulfur had been sublimed. Otherwise, if there's a big difference between those two, then we probably would keep it on the heat just to make sure that it can completely go, that it keep going all the way. For part A, I did collect it twice, but it didn't make it to the recording apparently, but there was no difference. They were the same weight actually for both of them, or at least it was definitely less than 0.02 grams. So it shouldn't make a difference either, so it's okay. But to answer the question more directly, no, we don't do any stats. We don't have class data to compare anything to, and we don't have any trials to compare it within our own runs. That's something maybe worth mentioning for the conclusion and the data in the error analysis, as you guys will see, you don't get perfect whole numbers, which is problematic. And that tells you that there was some error that happened, which potentially could have been circumvented, or at least elaborated upon where the error could have been if we had some stats to have done, or if we had trials, or if we had class data to compare things to.
Wait, so if we don't get actual whole numbers, like for example, for part B, I got like 1.2 for copper, and then like, should we round it down to 1, or do we multiply it out to be a whole number? Because I multiplied it out because that's what they taught us in Gen Chem, and I got like an empirical formula that's like not like realistic for copper sulfide. So I don't know what is better to do, because I can just round 1.2 down to 1, but that kind of seems weird.
So the value that's closer to the truth, meaning it's closer to what we actually produced, is rounding. The correct technique though is rounding, is going up like you did. So going up until you can get a whole number, basically. So you'll produce an empirical formula for molecules or for compounds that don't exist, but that's just part of the lab, and that's okay. I mean, you guys aren't graded on accuracy, meaning you're not graded on actually getting the right thing, especially, well, you're graded on like accuracy in that on the technique, but you don't we don't need to have actually produced a viable experiment. This is usually much more apparent when we're doing the experiments ourselves, where I would say at least in Gen Chem, usually like 2 to 3, so maybe like 1/3 of the class at most usually gets good data. Like they did the experiment. Some labs, only one group, some labs, no groups get good data. But definitely, usually the majority of groups do not have good data, which means that as long as you did the technique right and you understand the theory, that's all you can do. We're not looking to see that you actually, perfected the experiment. And that's especially true for this, since you can't redo the experiment, and that's just what it is. So the correct technique is going up. So you'll get crazy empirical formulas, but that's just what it is, and that's all they can do. If you guys round it down to, if you explained that in the conclusion why you did that, I think that's also fine. Probably, I'm not sure if I would just say that's like totally fine and just go 100% with it, or just say like it's mostly fine and give you like a minor penalty, like I don't know, like if let's say it was worth 10 points, 9 out of 10, because like if you explain that in the conclusion, like why you did this, I would say, yeah, it's true. It's not exactly the right technique, but that's good reasoning. So I'm not sure which one to pick between those two, but it's either way, it's like both good. So you don't really lose a lot either way. But definitely explain why you did that in the conclusion, and maybe how much confidence do you have in your answers. So when you guys are doing the data, like when you're doing the data analysis, which I was going to go over, I can show you like on Excel what we did or how I did it. Basically, if your technique is solid and valid, and if you refer to the videos and you're collecting the data that you see there, that's really all you can do, and that's all I can grade you on. And so that's all I'm expecting. I think that was a kind of a long way to answer that question, but.
Oh, and I have one more question. So the lab manual says that we need to put a data table in at the end of our conclusion. What should we include in the data table?
So I would like to see, let me pull up my spreadsheet. I'm delaying because I'm just thinking about semantics about what the data table could mean. So the data table, so if you show me basically all of your calculations and then all the data that you collected, that's all I want to see. How you organize that, there can be variation and you could still get full points. So the data table, probably more than anything else. I mean, I didn't make the report, so I didn't write the lab, so I can't say for certain. But the data table to me means all the data you collected. So for part A, part B on page.
Okay, so if I printed it out from the lab manual and just literally wrote the data in there, does that count as like the
That's
data
fine.
table?
That's
Okay,
fine.
cool.
So 57, if you just include page 57, that's enough data table for me. You will also need to include the calculations from part 50, from page 59 and page 60. And those, I don't really know, that doesn't really qualify as data. That's more like calculations. Obviously, that's why it's in that section. And then the results would be basically the empirical formula for part A and part B. I don't know if, let's see, what does this say?
Yeah, Dylan, so
Summary
for
table.
for the summary table, all I did was I just put, I just showed the empirical formula.
That's
because
it.
I figured that's what the objective was.
Exactly. That's so in general, always when you guys have the results are always the answer to the objective. And in this case, the objective was determine the empirical formula of copper sulfide and zinc chloride. So that's all it is. It's short, it's really easy, but I mean, we had to do a lot of work to determine that, but technically that's all we were interested in. And then everything else is a means to an end. It does matter to me, of course, the calculations, because that way I can see how you got the numbers, and that does matter. But yeah, that's all you need for the actual summary table. That's all you need. All right, maybe I can go over this. Let me share my screen. Just don't want you guys to write down exactly what I have. Well, you're gonna have to literally write down exactly what I have. So there's a little bit of, let me write this out. Actually, I can share the screen now. So this is everything that I did. So if you did something like this, oops, not the right thing. How do I do that? I don't need to be worrying about this. I just like having this defined. That doesn't look good. Well, something like that. And then these are the calculations. That's its own section. So if I were to have here calculations, basically. So this is the data. This is the where is it? Data sheet. This would be like the calculation sheet, and then this is the summary table. So if you include those things, then you should be fine. So hopefully you guys, if you guys have something different than this, you should let me know, because I mean, there's always a chance, of course, that I did this wrong, and we should, be comparing this. So these first two, obviously, just okay. So I guess I don't know what I need to really explain here. I thought the calculations are pretty straightforward because they kind of tell you what to do. The thing which seems most confusing, I thought, was this step. So basically, the only thing I wanted to highlight here, these two right here, again, the ratio subscript. The term is kind of confusing, but basically what that means is you're going to have one of them which is 1 necessarily, and the other one which is greater than 1. In this case, whichever one is larger than the other one is going to be greater than 1 because it's relative to this. So this is, if we look at the zinc, this is going to be the lower number divided by the lower number. This is the higher number divided by the lower number. So it's this thing relative to this thing, right? So that's like a roughly what this like should have been is like, let's say, well, not roughly, this should have been more like 2, or this should have been like 2 here, and this should have been 1. So this should have been smaller, this should have been higher, but that wasn't the case. So we did get pretty nice numbers though. Let's see, I got a question. I want to look at this. So, whoops, let me go back to this. Sorry, just making sure that people are getting addressed in the chat. Anyway, so we did get actually a pretty nice number with 1 and 2.5, which means we only need to multiply this by a factor of 2 in order to get whole numbers. So, you know, this would give us 5 chlorides to 2 zincs. It's not actually what we produce, but that's the right way to do it, and that's what Anna was asking earlier. It's a little bit less pretty here. This is actually just what would that be? Copper 2 sulfide. I can't remember if that's cuprous or cupric. I get confused with the inorganic metal prefixes for different oxidation states, or I just tend to forget them because I don't have to use them enough. But copper 2 sulfide, it should have been 1-to-1 roughly. It is roughly 1-to-1, but there was a little bit of error here, that being that we saw a relatively small number of sulfur. That's actually pretty surprising. I'm not sure why that would have been the case. The best thing I can think of is that that's probably the result of an uncertainty associated with the instrument, because if anything, you would get a higher sulfur, relatively high sulfur compared to copper, because there's going to be an extra film of sulfur that's on the crucible that was not sublimed, it was not heated enough. So that's my best guess, is just uncertainty with the instrument. The instruments actually were pretty hugely, they were not very good. There was a huge fluctuation that I would say it wasn't plus or minus 0.01 grams. It was more like plus or minus 0.1 gram, if not higher than that, which is pretty significant for this. So with that much uncertainty and the calculations, we're not taking account of the uncertainty in this lab. But if we did do that, we could actually probably maybe more reasonably determine what an empirical formula, the empirical formulas, and those might more closely resemble what we were expecting. We're not doing that in this lab though, so as is, all you can do is just multiply upwards until you can get to a whole number. Does that make sense? Okay. Well, all right, so let me know if you guys have questions on this. So I got a question in the chat. Make sure that you guys, so everyone should know this hopefully, but if you don't, the homeworks are individual Lima assignments that are in the assignments, tests, and surveys, I think, tab. It's maybe that's not the right one. I forget it. Assignments, tests, yeah, assignments, tests, and surveys. So make sure you do that. I have them already set up so that they expire at 9:30 every Tuesday, and they open at 9. So basically you have a week and 30 minutes to do it. If you've been submitting them with the labs, that's okay for now, but let's go back to the other one in the future. As in, let's make sure we fill it out on doing the online one. Because all of the all of the homeworks should be in the lab manual already. So under normal circumstances, what would happen is, under normal circumstances, what would happen is you guys would have quizzes at the beginning of each lab, and you would also have homework due at the beginning of each lab. The homework is basically the pre-lab. And then I would grade those two things, and then you have the lab reports. And in this lab, we got rid of the quiz. We made do with some of the loss of quiz by adding the extra assignments at the very beginning. That was the safety quiz and then the spreadsheet assignment, but that wasn't enough. So basically, you guys actually have a smaller total number of points available to you than we would normally, which is okay. It just means that the homeworks and the lab reports weigh heavier on your grade. It's actually probably preferable for you because I think these homeworks it's easier. Well, it just depends. For some people, it may have been easier. For some people, it may not have been as easy. But certainly the loss of having quizzes is actually pretty good because traditionally people do not do good in quizzes because, you know, you only have 10 minutes or something to do it. You're testing that material right then. You don't have any time to think about it really. So, I mean, it's good to come prepared for that, of course, but anyway.
Oh, do we have to do a pre-lab for this week's lab? Because I didn't get to do it before today since we didn't know what the lab would be.
Yeah, it's part of the lab report, so yes, but it's not, you don't need to submit it early. So unfortunately, yes, but it's okay. You'd have to do it anyway, regardless. The only difference now is that I guess that you can do it now. And if this is a problem, like as in like since you guys just got this today, if that's like not enough notice because you guys usually have the material earlier, if you guys want an extension on that, let me know. I'm not going to include that for the late days penalty or the late days that I've already given you. I'm trying to be extra flexible right now because I want to make up for this. But yes, later today, you guys should, I'm going to send you individually an email with the feedback. Please review the feedback and then we'll move forward from there. But yeah, just let me know if the time is a problem for this one because you didn't have as much time to prepare, but you still have an entire week to do it. So it should be okay. Any other questions? Okay, well, if that's it, if you guys are fine, then I'll probably just end the Zoom call. I'll be monitoring the Discord if you guys have questions. You guys were really good at helping each other on the Discord that I saw last night, so I don't really have anything to add. You kind of addressed everything, so I don't need to fix anything. But I think everything that was brought up there, I also addressed at one point or another here in this lecture too. So, but if you have more questions, you can ask there or you can email me. I can come back and at 11:30 as normal, and we can go over post lab. I don't know how necessary it's going to be. I kind of went over some of that already, but I can do that. Thing is, I guess I can run through the data that I have with Caleb's, and I can just calculate everything myself, and then I can kind of give you guys the guidelines about what numbers you should be expecting. The thing is that since you are doing this on your own, the numbers will be different. So basically, I just want to see what your technique is and make sure they're doing everything okay. Sound good? Okay. All right. Well, with that being said, then I'm gonna let you guys go, and I'm gonna get back to finishing the grades, and then yeah, you guys will get four assignments to do, 4 assignments. And yes,
Thank you.
Be sure to read the feedback for that because I want to give you guys the opportunity if you can make up points to make up the points or to do better in the future if there's any way to make it up.
Okay, then. Thank you.
Okay. All right. See you guys.
Thanks,
Thank
Dylan.
you.
Thank you.